In the final segments for this module, we're interested in actually computing the statistics that are shown in reading 4, the statistic number 1, and a related statistic that comes from the video that you watched. Although I have actually seen this exact same statistic quoted in other articles that I researched for this module. So this was a pretty common statistic that was quoted in various sources in late 2016, early 2017. I wasn't able to find a source for it anywhere, so we're just going to go from the data and see if we can support it. So to remind you briefly of what was found in reading 4, the specific claim that we're investigating is, quote, police are more likely to shoot whites than blacks. And that was supported by 2 different studies that we looked at in the previous video. The first claimed that whites were 20% more likely to be shot than blacks. That was the study that we found, and the original data set only included Houston PD data. And then the other statistic that was to support this claim was that whites are 1.3 to 1.7 times more likely to die by a police shooting than blacks. And that was supported ultimately by the killedbypolice.net data set. And then in the video, and like I said, in other sources, the quote is that a black man is 18.5 times more likely to shoot a police officer than a police officer is to shoot a black man. So these are 3 related statistics. They all involve the same 3 entities: white people, black people, and police. And so I want to see if we can find any raw data that would support any one of these claims. We might not be able to exactly compute all 3 of these things, and so if we can at least get one from some related data set, I'll consider that a success. In order to support any of these claims, we need to be able to compute some basic probabilities. So I'm going to go over the sort of number 1 most basic rule of probability. If you have some event or something that you're trying to describe the probability of, which in probability theory is called an event, we can compute what's called the empirical probability of event A. And that's what we're going to do here. So the probability of event A, usually denoted by P parentheses A, is the number of outcomes resulting in A divided by the total number of outcomes. So you're thinking about some sample space that has a specific number of outcomes, and you're looking at how many of those outcomes result in the event that you're interested in. So going back to the couple of claims that we are considering for this video, there seem to be 4 different events we could consider. So remember, we're thinking about the likelihood of police shooting white people versus black people. That's what both of these are talking about. And then the probability of a black man shooting a police officer and the probability of a police officer shooting a black man. So that's what I've written down here. These are the 4 events we are primarily interested in. And if we can compute some of these, we'll be able to make some conclusions about what we read in the articles. So the probability of a black person being shot by police, a probability of a white person being shot by police, probability of a black man shooting a police officer, probability of a police officer shooting a black man. So these 2 kind of go together. We were comparing these 2, and then the video quote was comparing these 2. The other piece of sort of mathematical information we're going to need to look at is something like these 3 phrases. 20% more likely, 1.7 times more likely, 18.5 times more likely. If we say something is some number of times more likely, then we're really saying that that number is a multiple of the other. And so when we're trying to say X is some number of times more likely than Y, we're trying to solve for the question mark here. And so we're going to have to divide. So that will be our last step. The first step will be to try and compute these probabilities, and then the second step would be to compare the pairs of probabilities by dividing. Let's come back to these probabilities and see what numbers we need to look up. There's a numerator and a denominator involved in each of these. The number of outcomes resulting in a black person being shot by a police officer divided by the total number of outcomes. the number of outcomes resulting in a white person being shot by a police officer, dividing by the total number of outcomes. For these first two, we have to think about what number of outcomes are we comparing to. And in the original, we're talking about the likelihood of getting shot by police based on race. So we would want to look at the race out of all possible shootings. So the numbers we'd be interested in the first two would be, for the first one, the number of black people shot by police divided by the total number of people shot by police. And then for the second, it'd be the same thing, but for whites in the numerator. So the number of white people shot by police divided by the total number of people shot by police. So if we can figure out these three numbers, right? There's three different numbers here. Number of black people shot by police, number of white people shot by police, total number of people shot by police. The denominator is the same in both. Then we would be able to compare these probabilities. For the other two, it's a little less clear. So here it's asking for the probability that a black man shoots a police officer. So clearly the numerator is the number of times a black man shoots a police officer. But what are we comparing that to? Out of what? Out of the number of times a black man sees another human being? Out of the times that a police officer sees a black man? What are we comparing to here? If we go back to the original, we're comparing the likelihood of shooting a police officer, and it's from the perspective of the black man shooting a police officer. And so this is certainly debatable. The way that it is worded here is my interpretation. So the numerators here are pretty clear. It's whatever the event is. So here, this is the number of times a police officer shoots a black man, which, if we can get these police officer shooting data by race and gender, it's probably in the same place we got our first number, the total number of black people shot by police. If we can also break that out as men versus women, then we should be able to find this in a similar source. But as I said, the confusing part here is what are we comparing to? And so here it seemed to be black man shooting a police officer out of all black men. So the total number of black men in the US. And then here, this would be out of all the police officers. So the probability of a police officer shooting a black man out of all police officers. That's my interpretation of how the statistic is stated. As I said, I couldn't find an actual source that was cited for this statistic, so I don't know if that was the original intention, but this is how we are going to interpret it and try to compute it. If we can find any of these 8 numbers, we would be in business. And actually, the total number of police officers was cited in article number 3 that we read. So it said that in 2012, the count was about 750,000. And it comes from this report. So the number of sworn officers in the United States in 2012 was 750,340. So we could try and use that number, and I'm going to put a note with the date as well. So this will be 750,340, and this number is as of 2012.